Okay, now it seems we have started officially with the recording. So welcome everyone. It's 2:00. So welcome to this second seminar or webinar leading up to the postgraduate course in Uganda, starting next weekend. It's a great pleasure so I'm Ola, and it's a great pleasure to just introduce the speaker and the webinar today quickly. Up on the screen here, hopefully do you see that I'm sharing my screen? No, you do?
Yeah.
Okay.
Yes.
I'm sharing here a publication from some years back by Connie and collaborators, quite a list of collaborators. It's kind of a hall of fame here with names that have been central in the work on participatory plant breeding and different approaches of involving farmers in plant breeding. So together with Connie here, you have Anja Kristink, Sally Humphreys, Bo von Stapit, Ronny Vernoy, Eva Velsin, Bert Visser, and others. And what they were writing about in this publication was really a change in perspective on how to work with plant breeding, a change in perspective from the kind of transfer of technology approach dominating during the heydays of the Green Revolution to more participatory approaches to involving farmers in the process or different stages of plant breeding. Some years later, from this publication, we published a book where many of the same authors contributed, and that was a sort of update in year 2020 of current approaches in involving farmers in plant breeding. And contributors from around the world wrote in this book. It's an open access book, so I can I can share the link in the chat later. With cases of plant breeding, with the involvement of farmers in different ways from around the world. But already when we wrote this book, we knew that this title was a little misleading because we said current approaches and perspectives, but we weren't able to get Kaue and Jakob and these new guys on board to write a chapter on their citizen science approach to variety selection. Because they were too busy working on this in those days. But today we have Kaue here. One of the people that has been spearheading this approach to farmer involvement in the plant breeding process. And just before I give the word to you, Kaue, plant breeding is, of course, an essential part of seed system development. And an essential sort of function in any seed system is this variety management and variety development. So although this course is primarily focusing on the seed systems and food systems of opportunity crops, knowing about these approaches to participatory plant breeding and involvement of farmers in plant breeding is important. So it's really great to have you here, Kaue, and as I understand, you will be giving a lecture of about 2 times 40 minutes with a break in between. So with that, I leave it to you and I stop sharing.
Thanks, Ola. I just allow me a moment that my computer is crashing. I need to change it.
Oh.
So I'm just it took some time to open the file, so I'm reopening it. So just a moment. Yes.
Even the people who are digitally much savvier than I am have problems with getting things going in online modes.
Yes.
It proves because Kaue is actually, aren't you in this digital inclusion expertise?
Yes, I'm a scientist that I must actually, yes, I am. I work in the team called the Digital Inclusion. So it's now it's okay, it's working. So do you see my screen now? I will
Very good.
share. Do you see like this now?
Yeah.
Perfect.
Yeah. Let me just also open the because I don't see you anymore. But I will trust that you can see me. So for me, it's a pleasure to be in this course, and thank you for the invitation. Of course, again, Ola said, that's like talking to. This work is basically built on on many experience that we had so far, and about the books that it's really cool to see all the names that Ola mentioned there. Like we learned a lot from the work of Ronnie, for example, and Dr. Sapit as well in Nepal. So there are many things that we learned, and then we managed to get to the level that we are now with what we call the tricot approach. So this work is something that started with my supervisor today, which is Jacob van Etten. And then he started it in 2010 in Ethiopia, with a small idea of kind of testing varieties with farmers, basically trying to digitalize or putting at excellence what Mother Baby Trials has been doing for many years. So I just want to put everybody in the same page that when I talk in this thing, I will talk about experimental agriculture as a product development. And then we think about that, it's something that should contribute to the improvement of farming, farming practices, and also something that is useful for farmers and consumers. It's sometimes it's not, it seems to be obvious, but if you think about, there are some people that for them they think more in other aspects, not what is really what the farmers need, and then there's kind of issues there. So one of the things can be a new crop variety, or even maybe sometimes we don't need to change varieties. Maybe we need to do a portfolio of varieties and also improve agricultural practices. So technology goes to that direction when I'm saying here. Of course, I also like to start by why we do that, why we do this type of things. And we have in our group, we focus in let's say, in four main issues that needs to be addressed, four challenges that needs to be addressed to accomplish what we like, what the things that we see in agricultural sciences. And I will bring also some of the ideas from the tech industry. I know that some of them will not be fair, so I just wanted to create a kind of correlations to things that we do in our daily lives in terms of how we manage other types of innovations in agriculture, or innovations in our world. So, for example, one of the challenges that we try to address in our research is basically the mismatch between what the client needs, in that case, what the farmers needs, with the supply, what has been provided by the system. So one thing, for example, that I can bring from the tech industry is about the experience of these phones, the Blackberries, They used to be kind of a trendy. Every professional used to have one to work with, and then everybody had it. But there was an issue, It's kind of too much functionalities in a very complicated design, and also something that was designing for one single goal, Like I could also relate that in when you think about plant breeding, is about high yielding variety. You have a variety that you focus on the yield, and that's it. But when these new phones, like let's say the ones that you can touch in the screen, came to the innovation, they were preferred by the people, because they have a compact design you can use for many stuff, take pictures, and they are very flexible. So I would call it a resilient variety, something that can be adaptable to various conditions. So this is something that we try to address now, the mismatch between what is being offered by to the farmers and what they actually need. Another thing that we also try to address is adoption. So this is a review from a paper from Graham Thiele, on RTB crops. And then you see here in the do you see my mouse here when I do that? Or do I
Yes.
need to put a pointer?
We see it.
Easier. So this is the age, of a variety after release, and this is the adoption, and the percentage of adoption of this variety. So if you think about, if you check here potato, it takes about almost more than 19 years, to adopt. and then the adoption is 35%, no? So it's kind of a very slow one. And I could relate that to basically offering to farmers to buy a iPhone 3G, no, which was the first one. It was like 19 years ago. And if you think about, I will go to the problem later now as well. But it's basically farmers now are getting things very late. But what I like in this review is that they say that the informal seed systems, now as they call it, but most people also call the farmer seed systems. You can call, I don't know what is the how did you frame this name in this course, Ola? But it could be any of these names, no, if you check the literature. So they say that the adoption was basically speed up by this type of systems, the farmers sharing with other farmers. So then with the problem of getting very late varieties or very old varieties, is that you occur into the problem of climate change. Like farmers getting things that may not be so useful or so adaptable to their current climates or current climate variability conditions. Another challenge that we try to approach is participation. So, of course, involving farmers and people in research is a challenge by itself. Working with many people, it's a challenge by itself because, of course, everybody has their own points of view, and there's many things on participation. So this is one thing, of course, but it is important. No? It's something that needs to be done. And if you check this research that was done by Misiko in Kenya with maize, you see that, for example, they were working with 600 farmers now in Kenya. 600, this is the total, 600 men and 600 women. And then they had all these crop stages now in the crop development. And what they see is that the farmers, they don't go, all the farmers don't participate in the whole process, no? And most of the farmers that go to planting or planning, they don't go to weeding, for example. So the participation is very low, and also with very scarce, like very sparse. They don't really go to all the crop stages that they need to go. And then the information that they provide is kind of very difficult to manage, and also the farmers don't see the whole development of the trials, no? Of course, there are many things related to that, logistical issues and low interest in some crop stages. And also, it's quite reasonable, this type of issues. And I like to put that, but I will come back to this later, no? Is the approach that was developed by Rhodes and Booth in 1982, developed, formalized by them on what they call farmer back to farmer, no? So this was a kind of idea to develop new potato varieties in Peru. So then this is another challenge, participation. And the other one that I mentioned before is climate change. So we know that climate change is going to affect crop production in different ways, and then we need to be ahead of that, no? And then there is a error here, but it's a challenge number 5, and then I will stop with the challenges and go for the solutions. Sorry for that. Is data capturing. So most of the things that people do, when we do research, we do type of research on mostly quantitative or qualitative research, but it's everything that we do are basically geographically dispersed, and then there is very small opportunities to aggregate and repurpose the data now to reuse it for other stuff, because everybody do their own small trials, and then they achieve this goal for this single trial. But it's very difficult to have this kind of holistic view of what is happening in the whole country or in the whole region, for example. And I can show examples of how Tricot has supported that. The other thing is that there is a very little focus now on the opportunities that well-structured data can provide. So that's what something that I particularly developed. Now, I am a forestry engineer by career, but I also worked a lot with farmers, small communities in Brazil when I was studying there and also working there. But something that actually that drives me is about it's about data, no? Because I know that with data you can get into into real like insights, and you can get to decisions that can influence or can improve the lives of the people involved in the research. And basically, this is what I do in my group, particularly, you know, working on this type of approaches to improve the with the data, no? And then you improve the knowledge or get knowledge, and then you go to action based on that. That's one of the challenges. But basically, this is just an overview, and I know that in this course you will be seeing lots of this, so I don't need to go deep into this. But it's basically, this is how crop varieties are introduced. You know, you do kind of sometimes you do farmer management centralized trials, or you invite farmers to locations, and then they do the assessment on that, and then they judge, and then you get into a set of 15 to 30 materials that farmers are willing to use. This is very common. This is was developed in Nepal. This picture is from India, from the work that we did in Seed for Needs. So this was basically how this was done there, and this is how it's done generally, you know. But we think that this type of research is good, but there are again the challenges it still needs to be addressed. Now the five challenges that I mentioned to you, and we believe that needs to be a change in the way that we do experimental agriculture. No, again I will just go. I like to do again observation on how things are done. No, before or why we do stuff the way we do now, and then I will go back in the history of the agriculture experimentation before I show to you the way ahead, you know, that we propose in our research group. Of course, agriculture experimentation is something that is very old, but formalized in terms of let's say statistics and something like this. It's something that it's a very new, no, it's 100 years old thing. Before that, of course, farmers used to experiment, but I mean, formalized in terms of mathematics and things like statistics is new. The idea here is that Fisher, no, it was that he was hired by these guys in UK to develop a mathematical way to deal with GBI, because they want GBI was a nuisance effect. They wanted to get rid of this, so they wanted to control GBI, and that's how Fisher came with the RCBD trials, no, like randomized control block design trials, a way to deal with GBI as well. And also, of course, by that default, he developed ANOVA as a mathematical way to test differences in the means for the data that comes out of this. Of course, to set up this type of experiments, it was very complicated for if you think about how things were used to be done before that. So basically, the trials used and had to be centralized, and also was very difficult for farmers to be implemented. No, so can you imagine a farmer setting up a trial with I don't know, 50 barley? No, because this started in as a barley research for a breed for these guys in UK, and also so this started like this. So can you imagine farmers setting up these 50 trials barley just because it needs to be randomized and then needs to be in the same place? So it was very difficult for farmers. And this paper by Parolini 15 talks about that, and also talks about how difficult this and how this created a kind of gap between what researchers do and what farmers do. And then this was 23, no, to 1923, and then the Green Revolution came, and then all these things on improving breeding, you know, and all these advancements in breeding, and then we had this gap, you know, between what breeders do and what farmers are doing, you know. And it's funny because it took from Revolution, or if you think about the Green Revolution in the 60s, for example, or 65, let's say 60s. So it took almost 20 years, no, for the from the Green Revolution to this moment, you know, when Roots and Booth they came with this, well, they formalized these what they called farmers back to farmers. It took quite of time to actually realize that the farmers were by not being involved in the research, they were kind of the adoption was really low. So the farmers were not adopting them, what the breeding teams were coming out with. So it took some time. And also, if you think about how people approach that, always approaching these as a kind of sorry, don't judge me on that. I'm not judging. I work a lot with socioeconomics approaches, no, but in social sciences, basically what we do here is lots of social sciences. But the way that people say that, yeah, this is I'm let's say between brackets, no, they say, yeah, this is social science. This is not, this is something else. So this is how people used to treat this type of research, and not taking it as part of the routines in breeding, if you think about that. So, of course, there was more challenges on this type of participatory research to be addressed still, but this type of research in the 80s now made this kind of advancement and showing the need for including farmers in early processes in breeding or product design. With that, people started to invite farmers, no, to do research. Still, was still centralized locations, but then farmers were now part of this study, and of course they are brought back to that. But again, the way that is done is basically farmers visit a plot that is managed by someone else. They visit there, they assess what is happening there. But again, they are just having a snapshot of what is happening in the plot. It's basically one day field visit. They see. I also published paper with results of that, and we can see lots of the things that can come out of this, but still is snapshots. Now, you don't know how these farmers don't know how this variety will perform in their location. So it's basically, again, going back to the tech industry, is like if you go to a phone store, like a telephone company, and then you try some phones, and then you use the camera, you take some picture, you see how is this is done, but you never know how long the battery of your phone stays. No, you don't know the autonomy of the battery. You don't know what happens if the phone goes down, and if it goes to break, or if water goes into it. So you never know what's happening because you're not using it in your daily life. So basically, this is one of the issues in this type of approaches. And then, of course, now in the new year era, no, a new millennium, and then Snap, which is now a scientist in in CIMMYT. She came with this approach, which Whitcomb classified as a high client-oriented breeding. The approach is called modern baby trials. I didn't even write modern baby trials here because it's kind of MTB, MBT is kind of a very, very common way to put it in that way. So this is basically modern baby trials, no? Which was the first attempt to actually do testing or first documented thing, attempt to do on-farm testing in a more standard way with very simple experiments that farmer can do without changing their whole routines in the way they manage the farms, and also farmers observing this across the whole crop cycle. No? So it's basically you using a new product, a new phone, or a new whatever thing comes out in your daily life, and then you can see if it's something that is actually fits your needs and something that you would like to buy. So modern baby trials, I think it was very revolutionary in that way. And if you read the papers by that time, like the papers from 20 years ago, modern baby trials was already considered as a very revolutionary research. If you think about participation. And basically, Tricot, the approach that I will gonna tell you is basically it has lots of model baby trial. You will see that when I start to talk about. But there are some differences, and I will also talk about these differences. So just to summarize, is basically this. No, what is the issue when you think about statistically on this type of trials, no, that are centralized, and when you think about model baby trials or tricot trials, the advantages, no. So if you think about RCBD trials, which are centralized locations, they are performed in a limited set of places, no, and then tend to have low external validity. Like the validity of the data that you receive, that you get from that type of trials, they have more internal validity. They will be very good to be used under the conditions that the experiment was set up. If you think about trials that are decentralized and on-farm, the opportunity here is that you are going to do this in a wide set of environments, and then you have data with higher external validity. And in our team, what we do is that we also use the climate, as a kind of covariate. We don't, unlike what has been doing when Fisher came with the mother baby with the RCBD trials. We don't treat climate and management as a nuisance effect, but we treat it as a covariate in the model to try to understand why some varieties perform in one way and why others not. So basically, this is how we do, and also we have the socioeconomics. Today, at the final thing, I will show to you a new approach that we developed with recently, actually yesterday. So you're going to get the first time lecture on that. And then I will show to you things that we do now with the socioeconomics of farmers, how this can influence decisions in breeding or seed systems. Again, external validity, internal validity is things that considers factors that goes beyond the experiment. This is external validity. And everything that we do with Tricot is focusing on getting data with high external validity. Tricot, it's the acronym for Triadic Comparison of Technologies. And if you think about Tricot, is based as I said already, it's based on existing on-farm trial approaches, like mother-baby trials or seed packages, like what WordVeg used to do before. Now WordVeg adopted Tricot as their let's say normal practice approach, like their approach for on-farm testing. But before that, they had the seed packages. The difference between Tricot and mother baby trials that Tricot you have a focus on the babies, like the babies are the trials established by the farmers. Despite different to mother baby trials, farmers they will test only 3 technologies out of a larger number. So sometimes if you're talking about a seed systems trial or a breeding trial, it can be between 10 or 20 varieties, and then the farmers will test only an incomplete block of 3. I have a slide about that. Uh, the technologies they are assigned randomly. So in modern baby trials or other approaches, the farmers they generally have the choice of which variety they will test. In Tricot, the farmers don't have this choice because we want to have a balanced design where each variety are tested equally. So we want to avoid bias in the data. Again, there is lots of focus on how the data is generated and how we analyze that, so then we can have more insights. The assessment is done using rankings. So the farm is a kind of best worst scaling. So the farmers will tell us which one is the best and which one is the worst for a set of traits, and then by default we know which one is the middle. And also in most of the cases, the farmers don't know the variety that they are testing until the end of the trial. So when the trial is over, so then the farmers will know which variety they tested. Why? Because we want to avoid, mostly when we are talking about a seed systems trial, we want to avoid the bias of a farmer because they knew about a variety, they heard something bad or good, so they start already with a feeling about the variety. So we want to avoid that. And then there's again strong emphasis on how data is collected in storage. Tricot employs the best of existing approaches. Citizen science is one of the approaches where we do the scale. Like it's kind of getting generating information for many people, not from many people, like around and scaling that. high volume of data generated by citizens. In that case, citizen scientists are the farmers or consumers when we do consumer testing. And citizen science is basically that, when people know about the topic, but they are not formally trained on that. So it's like a very common in bird ecology in US, where you have all these papers, about bird migration and so on. And basically all these papers, they are all these research are based on contribution of people just do bird watching. They go and they watch where the bird were present. They identify. They send it to the app that Cornell Lab develops, and Cornell uses that to do the bird migration research. On-farm testing is very common as well, mostly in the north in US and in Norway, for example, it's very common that breeding companies get data from farmers. Now, farmers, they need to register the production of the cows anyways. So breeding companies use the data that farmers collect for them for free. They use that and then they input that into the genomic models that they use to select the new bulls, no? Basically, in Norway, there is a company that does that, and they actually offer premiums to the best progenitors, no? So this is basically getting the performance of a genotype under real conditions. Digital agriculture, no? I'm not talking about flying drones. We have projects on that, but this is not what we do here. It's more about getting simple trial designs, tools, management, and data collection to support data analysis. And of course, participatory research, farmers as center, on the design and also informing the processes, so then people can get the best uh, overall appreciation of farmers at the moment, and then you can take decisions based on that. So, and this picture is from Seed for Needs in Ethiopia, where we did lots of tricot trials. Basically, tricot works in that way. We have our tool, which is called the CleanMob, which is a software online that you access in your computer. You don't need to install it. And then you have, let's say, just for the sake of fitting this screen, is 5 varieties. And then each farmer, you do the randomization on the package creation. You do it on CleanMob. And CleanMob will create for you many packages, as many as you ask. And then we'll assign three varieties per package, and then we'll code it as A and B and C. Now you have this code, and then you have 3 varieties in each package. So this is an incomplete block design. So if you think about the statistics around that, it's an incomplete block design. And then you prepare the packages, you put them in a bag, and then you go to the farm. You give the seeds to the farmer, and then we use ODK Collect, which is an app for Android that you download it, and then you can link the trial data with the platform. So then farmers will establish that in a trial, like A, B, C side by side, and then farmers will do the observations as rankings, telling us which variety performs best and which one performs worst, and by default we know which one is the middle one. So the data is aggregated again using ODK and then sent back to CleanUp, which do some basic analysis for you. But also you can download the data and do your analysis deeper, more if you want to go deeper into the analysis. How the incomplete block design works. It's basically this. Each line here is a block, and each line is a farm as well. No, each line is a block, and then you have your design here. And if you see here, you have some check varieties, or control. I don't know how you call it. Normally, the breeders they call check varieties. So you see that the check variety is also part of the design, but is not present in all the blocks. Because if you put the check varieties all the blocks, you are basically creating a bias towards the check. So we don't want to have that. We want to have a balanced design. And if you read that blocks here, you see that each variety is tested between 5 to 6 times. So every variety is tested equally, but at the same time they are compared to each other at least twice, at least 2 times. Okay, so they are co-occurrent in the same block at least 2 times. So then this creates a kind of a very structured and very robust network for testing, which allows us to distribute varieties. And even if some farmers drop the experiment, you can still keep the consistency of the trial because they are very well connected. For those that like football, I have an example, no, because people say, why don't you put the check in all the plots? Basically talking about football in US or in the last World Cup, when you have the group of Japan, Spain, and Germany and Costa Rica. And then there was a day that they had a match between Germany and Costa Rica. And then it was really interesting because before the game started, Costa Rica and Germany never had a match before. But before the game, FIFA already had the statistics, the probabilities that of which country are going to win or not the match. Uh, Basically, Costa Rica had a 2% chance and Germany had a 91% chance of winning. But how come FIFA knew how to do the calculations if Costa Rica and Germany never played against each other? Basically, because Costa Rica and Germany already played against common players, which were Spain and Japan. So basically, FIFA got the statistics from the previous games that these two countries were involved and calculated the probability of winning, and that's how they got. And I did the same, and this is the same probabilities that we get from the Tricot data. No, I did the same, but the difference is that Costa Rica, FIFA considered also a draw, and in our case, I decided to not consider a draw. I intentionally decided not to do that, and then you get almost the same probability, 89%, and FIFA said it was 91%. So it's very likely that FIFA already also used data from other matches that Costa Rica had with other teams as well. So that's how they got let's a lower probability. But again, I'm just saying that you don't need to put everybody to play against each other to get the results that you need. You just need to have a common player with informing the results, likelihood of the results. So then you can get your probabilities, no? And the probability of winning is basically what Tricot data give to us when we calculate the rankings, now when we do the ranking analysis. Is basically this type of data that we get. And the name of the model is Placket Plus model. I will not go to these details today, but I can do it in another opportunity. So basically, the analytic tools that we do on Tricot is this. No, we have our software here, CleanMob, and also like a kind of a suite of tools. Also statistical tools, and also a socioeconomic tool that is called ROMIS, developed by Erie, Mark van Wyk. So basically, we have on-farm trials. Farmers provide, they do the testing, they assess and they inform the breeders how the people implementing the trials, how the varieties perform. We have many locations, no, and then we do it across seasons. So it's 5 seasons here. So with that, since you have the GPS and you have the planting dates, you can easily get, well, easily today, but it took some time for me to get to this. You can easily get your map with the varieties recommendations, for example. This is one workflow that we developed, but there are many others that I can show to you today still. I still have 5 minutes. So, so just in summary, Tricot, in Tricot, each farmer tests 3 technologies out of a larger group. So between 10 or 20, if you're talking about seed systems trials or breeding trials. I can just, if you want to ask me what is the difference, is that, for example, in the project that we have with Boulder project, now I don't know how familiar with you are with this project, but ideally we want to test more lines. So this is basically if you put in a breeding framework, it could be a pre-breeding trial, because when you test lots of varieties, you don't want to know which one is the best one. You want to know which group of varieties are the best. So when you want to test between 10 to 20, you want to identify the best variety or the top 2 varieties in a specific group of farmers. And in the trials that we do with more varieties, we don't want to find the best variety, we want to find the best batch of varieties. So that's the difference. Farmers, they actively observe the performance, the development of this trial across the whole season under real farming conditions. And also, I mean that we don't actually prescribe management practices. We want the farmers to do what they do. And basically, this is a research that in Nepal, we founded literature about that. Farmers, they rank the technologies reporting which was the best and worst for a given trait. Tricot in practice is basically this, and then I can finish my minutes. The varieties are distributed like this in 3 packages. So this is a bean trial in Nicaragua. The farmers also get a booklet, so then they can write down the answers if you want, or the data can also be collected in ODK, as I mentioned before. And if you have a budget for that, you can also have a booklet informing what is the goal. Basically, today I'm advocating for people to have that as a kind of a consent form, no? So you send out this to the farmers and you inform the what is the goal of your research, which type of data are going to be collected, and if the farmers consent or not to be part of this research. So this can be seen as the consent form. Of course, always trying to comply with the GDPR regulations. Trial setting. Basically, the trial is set like this, side by side, A, B, C, on the same day. The plots, they generally are small to allow comparison, but not too small to avoid the edge effects. And ideally, the farmers should do the same management that they do to the main plot here. So they should do the same management. We want to see how these varieties perform under farming conditions, unless management is part of the trial design. Farmers, they do simple observations. No, they are the ones actually observing. The extension officer could be there just helping them, but the farmers should be the ones doing this. We have very cool videos on YouTube showing how this is done, so I can send the links later. And then the farmers will tell which one which one is the best and which one is the worst for a given set of traits, depending on the crop and also depending on the goal of your trial. Under the Boulder framework, the project that I mentioned before, and also Thousand Farms, we are developing standard operating procedures to get a very let's say defined set of traits per crop. So then you can collect the data using the same let's say community-based SOPs, now the standard operating procedures. The data collection is done can be done using ODK. Or can be done collected on paper and then submitted through one tool that we have called Enketo, which is basically an ODK like based in browser. The final thing that I have to tell you is about a very important step, which is the farmer feedback. So at the end of the trial, generally the farmers, they are engaged in a community organization generally when they are working in Tricot. So sometimes they already know each other, so they interact, they share experiences. It's very funny when the farmers, they go and then they say, yeah, but my neighbor variety is better than mine, no? So they start to argue that, and it's really funny. They get really curious about the part, knowing what they received and what the other farmers received. But by the end of the trial, project managers need to do a kind of feedback with the farmers, which is an integral part of this, no? So the farmers they will be invited to workshop, and then they will talk, and then they will receive a report of what what worked for them and what did not work for them, and then they will compare results with their colleagues, and say what they think, and there is a kind of now we are developing a kind of guidelines for that, because also people used to do their own ways, and then in Nicaragua there was a very nice structured way of doing, and now we are just documenting this part of the approach as well. So basically, this is the feedback. And just to clarify, Tricot is the approach, and CleanUp is the software that we developed. I will go very quick to that one, just to tell you that we collect rankings, but also we can collect a grain yield or yield estimations. So there are some ways for that. One way is that the farmer can put the seeds in a can or in a pot, and then tell us how many cans was filled with the seeds, and then we transform that into yield, into grain yield in kilos, because we have an equation for that. And then we can get very accurate estimation. So basically, this is a plot showing how was the estimation done by the farmer and how was the estimation done by the technician. And basically, it's basically the same. The only difference is that farmers, when the yield is very low, when it's like below half of the can, the farmers, they say that the yield is zero, and the technicians tend to be more precise in the fractions. But for the farmer, there is a reason for that, because for them, if the yield is below half of the can, they say that they cannot sell it. So for them, this is like I didn't get anything. So basically, that's the reason. So there is a psychological reason for that, and that's what I'm saying. Everything has a psychological reason. Also, I see plant breeding or agriculture experimentation actually as a social science entirely, and explain that you explain with the biology or the way around. But it's basically a social science that you can just do biology with that. Uh, so there is another one which is also in Ghana with cocoa. I will not go to details, but basically it was doing visual things. And also we see that the visual thing, it's much more accurate for both approaches, for maize and cocoa, than for other things, like when you get things like weird like this. Also in Nigeria, farmers do participatory assessment by just having lead farmers. So you have a farmer which is the head of the community, and this farmer is the one taking the measurements in with something that we give to them, and then they are trained for that, and it's also they are paid for that. Farmers in Tricot, they don't get payments, but these guys they get, because they are actually doing a work outside of the collaboration, because I will talk more about that in the next session. To finalize that, I would like to see that this is not a biodiversity international thing. It's something that is done with many people. Like really lots of organizations involved, CG organizations, universities, mostly Wageningen and universities in Norway, no, and then NARES, no, in Africa, lots of them, and so this is basically something that is built on a multi-institutional partnership and built on trust, no. So this is really something that I'm really proud of it. And just to say, for example, last year we came with this paper, which is basically 84 people involved, where we talk about Tricot as a retrospective over the last 10 years. And we had people for like, I don't know, 40 organizations involved here, which was really something really cool. I will stop now, because in the next session we will talk about learning, what we learned with Tricot. And I leave it, I hand it back this to you, Chair. Who is the chair?
Wonderful. Wonderful. I don't
Yes.
know. I think Connie, you are actually the chair, but I'm jumping in here. I saw. I don't know if you saw it there in Wageningen that there are a few questions. Do you need tea urgently, Kawa, or can you take a couple of questions?
I can take it. I'm at your service actually. So I just decided to stop it so then I don't stay talking
So
for long. So then you can,
yeah.
yeah.
No, but this was very good, very good. So there's a few questions there. Do you want to post those questions yourself, Nguyen? I see one. It's
So
also
I have a,
written.
Yeah, it's for me. I was
Yeah.
just wondering, but I think at some point you already somehow explained this because I a bit got lost on how we approach. So what is the aim of this kind of experiment? Because somewhere I read that the technologies are normally hidden from the farmers. So, and then you explained that because you recruit the farmers based on their interest. But as far I understand that this kind of experiment should serve farmer in some way. But if they are not known about what they are testing, then what is the final aim? So you will come with the overall performing the best performing variety or technology to introduce to farmer or to for yourself. It's kind of that. Yeah.
yeah, so Tricot started actually as a seed systems trial. No, ideally we wanted to improve adoption of a new drought-tolerant varieties that the people released in Central America some years ago. This is one of the goals, and also in India there was the same goal. In Ethiopia, the goal was to test gene bank accessions to restore the breeding population in Ethiopia.
Yeah.
But if you think about the seed systems, the design it was hidden in the beginning just to avoid farmers to get a bias evaluating something that they heard something good or bad in the around with the farmers. So this was the one thing. But at the end of the trial, they know what they received. And in the Nicaragua trial, they actually had the chance to choose to get for free some seeds. Like, for example, they said, okay, I received, I don't know, INTA Matagalpa 2020. And then in the meeting where they are meeting there, they agreed which variety they would like to get 5 kilos for the next season to plant. So they will get to know the name of the variety, but by the end of the trial, just to avoid issues with like a kind of bias. But in Laos, we are doing actually we are conducting a tricot trial in Laos, and then the farmers they know what they are evaluating because it's a forage trial. So they know
Okay.
exactly what they're evaluating, and the goal is just because they are not judging the variety, they are judging a kind of a
Yeah.
mixture of forages to adapt them to dry conditions, because a very big problem in northern Laos is basically drought in the winter, as I am aware of it. And then that's the goal, but and then they know what they are evaluating, because also there are some times that it's basically impossible not to know. For example, this one they are testing crotalaria, this kind of forages, which is very easy to know. So depending on the goal of your research, farmers can know what they're evaluating, but just be careful. Yes.
Okay. Yeah. Yeah. Thanks. It's clear.
Do you see the other questions there, Kawa, in the chat?
Uh, so this is does the external validity of tricot approach takes into consideration much better compared to other approaches, the socioeconomic conditions, constraints, challenges, needs of farmers? Yes, I can show to you one example with the results that we got. This is going to be the final slides that I represent. How this type of noise that people sometimes consider as noise can be grouped in a kind of creating farmers' characteristics that are very relevant to take decisions. Uh, The PowerPoint is still on World Cup. Oh,
Well, it wasn't for me, so I think that was probably a problem on the receiver end.
what is actually hidden by the farmers is just the name of the variety, just the name. But the farmers will, if sometimes even depending on the study, for example, in Norway, we are going to do trials, tricot trials. So the varieties will be hidden by the farmers, but the farmers will know which varieties are tested in the whole trial, you know? We are telling them, look, we are going to test 11 things. These are the 11. You are going to get 3 out of this, but you don't know what you are going to get. But just for you to know, the options are going to be among these 11. This is one approach as well. Major limitations of tricot approach. I can also talk about that
In the next session, right?
in the next ones. Yes.
Yeah.
Yes.
I think we take 5 minutes break. Is that okay?
Yes.
Yep. See you in 5 minutes.
Okay.
Okay.